Okay, good afternoon to my programming students. There was already some initial panic about there not being a stream. The very first thing we gotta make sure is that everybody is in the right place and doing the right thing. So let's look at the course website. On the pinned post here on Discord, we have the website, we have the Twitch that you should be looking at now, and there's the YouTube playlist where this recording will also go. So I am going to open the course website, bringing it from the other monitor so that we can figure out what we're doing today. So everybody should have read this last week. I've been adding here all the GitHub repositories that you guys have been creating. Remember that everybody needs to one time fill this registration here. If it still says interrogations, then it means you haven't registered. No one has any points because we've done no homework yet, but your study program should be showing up. If there's interrogations, it means you haven't done this and you need to do this. You need to put here an email that you're going to use for the homework. You're going to put your student ID, and you're going to select your study program. If the study program doesn't appear, please let me know and I'll add it before you click on the button. Everybody has to do this one single time. If you already did it, please do not do it again. I'm going to link this on Discord. Another thing you were supposed to do last week, and no matter how many times I tell people that they still need to do it, I'm afraid they don't. So there's this little survey about background information that you also need to fill. If you've already filled it last week, please don't fill it again. It's only a one-time thing as well. So those were the things we did last week. We also learned a lot of stuff about basic concepts like conditions and cycles. We were looking at some Python. We were looking at some C. So we're going to continue from that. If you have sent your repository, apparently, for like Brian here has sent it twice. Let's go clear out Brian. Please click on the link. It should be your Discord name, and check if it's pointing to the right place. If it's not pointing to the right place, then I need you to put it on the channel again. Okay, Brian should be only once now. And we're still waiting for people to post theirs because I know that Ags isn't actually signed up. And I know I have 73 people on Siase. So we're definitely missing out on some repositories. It's not urgent yet, but you really do need to have it made by next week. So this is what we did last week. And today we're going to be messing with the command line, especially we're going to be messing with the compiler. And last week when we were discussing how to install the compiler, we had a wonderful suggestion that I need to now find. Actually, it wasn't a different channel. I tagged you guys there. One of my former students of discrete math found a thing where you could use GCC online. This one here. So this is wonderful. So if you haven't installed anything and you're a little bit worried about installing things, it's a valid option to use this online thing here. I'm gonna try to zoom in on it and I hope it doesn't break entirely. So basically what I do in my editor and in my command line, you could do it here. Let's try to make everything fit. This seems to fit. Making this a little smaller. So you would write your code here. We can take the comments away. I I hate it when those aren't on the same line with the thing that starts them. Really doesn't matter what number you put here. We'll talk about that later. Okay, have to choose a language. Going to choose C. Okay, it seems to have worked. And it outputted testing. Okay, so the bad thing here is that it's hiding the fact that there's two different steps to the process. One is the compilation and the other is an execution. But you should be able to work just fine here. You should be able to save them. And there should be a way to integrate these to GitHub somehow too. So this is a good option if you do not have a GCC with some editor installed on your computer. Let's get me a new terminal window to start working with mine. Lots of people saying hi. Okay, so let's go to the repository. I made one that's called C, and what we had there is this file called test, where we wrote all the ifs and the whiles and the do whiles and whatnot from last week. So just as a quick recap, let's look at all the things we did last week, make sure that nobody's confused about any of this stuff, and then we're going to do a little bit more work on this same exact line. So basically standard input and output, it really means keyboard and screen. So I could read keystrokes from the keyboard and I can print stuff on the terminal. The first thing here, this is the return type. What the, I keep forgetting I'm writing C. What the main program here will produce. It will produce an integer, which means a whole number. Let's put some commentary in Spanish too. Then we have two parameters here. We're going to look at those later. This is the number of command line arguments. Let's actually write that here too. This is actually a pointer to an array, but we're going to talk about later about what pointers are. So let's not hyperventilate if we don't know what that is. Then we here made variables, which means that we have storage space where we could put values. We can assign using the equality a value to a variable. I don't think it really likes my commentary now. Why doesn't it like it? It hurts me that it doesn't go inside. Let's compile and see what I broke. It should be fine. I'm gonna change my way of making comments to make my editor possibly slightly happier. Still not happy. It's entirely killing me that it stopped putting the stuff on the inside. Yeah, something about those comments messes with it. Maybe it gets confused when there's... Yeah. It gets confused when there's parentheses there, okay? So that's a condition. This is the while loop. So with the condition was we put something here that's going to be true or false. If it's true, it does this stuff here. If it's false, it doesn't do anything. Let's make the other variants of the if. So this is the first one. Then I'll make another one that first checks the same condition. Let's actually put it the other way around. So this is going to be the first branch of the second if, because that's when the condition is true. Then we could do a second branch. For when the condition isn't true. And I could also make an arbitrary number of else if thingies here. So now I've edited the code. While I'm moving things here, I occasionally save the file. If I don't save the file, nothing will be different outside of this editor. Once I've saved the file, if I would want to run the program, if I just run the program we did last week, there isn't going to be a first if and a second if, because the changes in the file are not reflected in this executable file. This executable file that we have was made earlier when I compiled, when I was testing if everything was okay, but that was like 3 minutes ago. If I wanted to show the stuff I made after, I could compile, but now I have an error because I keep forgetting this is not Python. It's actually pretty good that we have an error because you can see what it says. It says that on this file, on this line, in this position, I am trying to call a function print, and it doesn't exist. And it's even saying here, did I maybe mean printf? And yes, I sure did. So if I change all the prints to printfs, now it works. And when we look at the executable, it's just been updated. So now if I run my code again, it's now running the second version instead of the first version. Yeah, it selected the branches hello, second branch, and final branch. Let's go change the numbers. I need to recompile, and I run, and now it did different things. So what if I didn't want to recompile it every time I want to change the values of x and y? Maybe I just want them to have values that come from something that the user can do without compiling. That's what all this stuff is for. So let's play with this stuff for a little while. We're going to try to figure out what information we're getting from the operating system. So let's try to make a for loop that tries to figure out how many parameters I have and what those parameters contain. So let's make a for where x starts as 0. X is going to go up to argc minus 1 in steps of 1. And what I want to see is what does args contain in each of those positions. So I am going to want to print the string of the parameter in that position. And we could actually also print here the value of x so that we know which one is which. Okay. And let's get rid of all this rest of this stuff here. Let's just make another return right here. See if it gets mad when I compile. It doesn't care. And now I will run my program. Yeah, to reply to what Diego is saying, C is like simplified English. Okay, so now I just wrote it, the a.out. So I had a parameter 0, that was the name of the executable. What if I wanted to be called something else? I could compile it and tell it, make it called something else. So then I could run something else. And now the executable is called something else. If I write more stuff here where I call my program, I can have the program be aware of every single thing I wrote. The problem is now that these are characters. So the 1, 2, 3, they're actually not numbers. They are characters. So if I would try to do math with them, bad stuff will happen. So we would have to first worry about how do I make numbers? Like if I want to take x and y from those values there, how do I make them numbers? The first thing we're going to always look at is our C reference card. Let's get rid of this lemon that we made for another class. So, does it say somewhere here, how can I make a number of a string? So we could look for operations that have to do with strings. None of these mention that they're taking numbers. This says if something is a number, if something is a space, very useful, but not what we wanted to do. What we need is a conversion from one thing to another. And we have a conversion here. Convert string s to integer, a to I. Okay, marvelous. And it comes from stdlib.h. So let's try to learn to do the very first thing with stdlib.h. Let's try to figure out numbers from these parameters. Now, if the person who calls the program doesn't give us that information, our program's going to fail because it won't be possible to convert the value. But let's try. A to I, let's try to suppose that the one right after the executable name would be the value of x, and the one right after x would be y. And then we would just look at what these values are. New line, x and y, to see how badly we've broken everything. And let's just end the program here before we do anything else. Okay, so I need to recompile. It's still called something else. And now remember, it's supposing that there's going to be a value for x immediately after the name of the executable and a value for y immediately after that. So now in position 1 there was 23 and in position 2 there was a 12. So I took the values, I made them numbers, and now I can actually do number arithmetic with them. Compile, run, I can multiply them. Whereas if I don't do any of this stuff, of this conversion stuff, if I, let's say, decide that let's put the argument in position 3 to a third variable, let's have a z. I'll actually just try to do it as if I were expecting it to work, so we can look at what kind of an error it's going to give. So now it's going to try to tell me the value in z, and it's going to try to multiply it by x. I'm not expecting this to work, because this here is a string. It's a %s. And this thing made it into an integer. And here we're not converting, so we're doing something horrible. Okay, first of all, I get a compilation warning. It's saying that this is a bad idea because one of these things is a char asterisk and the other thing is an integer, but it compiled anyway. So now if I try to do this, bad shit happens. That's supposed to be an 8, but its value is actually this because I didn't convert it. So it lets me compile and it lets me run, but it's not doing what I want it to do. Okay? So sometimes your code will compile and it will run, but it's going to do the wrong thing because you didn't check step by step what you were supposed to do. If I also convert the third variable correctly, then I can do reasonable arithmetic with these numbers. Okay, let's try in Discord if we have some panic reaction to this. I would like to clarify here that the reason why you have interrogations isn't because you're from a certain study program. Everybody has interrogations in the beginning. And for me to add a new option to the list, what I need you to tell me by this very channel here is the abbreviation and the full name of the study program in Spanish, so I can go add it on the list. If you wrote the bad one, like by accident, like Julio here, then I need to go change it, which means you need to send me a direct message saying, this is my student number and I'm supposed to be from this study program, because I have to go manually edit it. And I can't do it now because I'm teaching a class now. I have to stop teaching class to be able to do it. So this is kind of a bad time to be doing these registration things because they were kind of supposed to be done next week. But I'll look into them as soon as I can. So we're making a poll about this argc thing. It really doesn't matter what it's called. The args thing, it really doesn't matter what it's called. And this A to I thing, that really matters what it's called. I'm going to demonstrate that it doesn't really matter what these are called. Works just the same. But this thing, I can't make this thing up because this thing comes from the library. And usually when you're programming, it's a good idea to type here what stuff are you using from each one. Like the printf is coming from here and the A2I is coming from here, so that you know if you actually need them. If we have questions about any of these details, the number of arguments, the accessing the arguments, and the use of the A2I, you could type those questions on Discord now. We're going to come back to them later on, and the information in the book will be very helpful when you read the book. But I just need to know if there's a question you would like to ask before I do anything else. So stuff like int and for and if, we already were looking at those last week. If you weren't here last week, you really need to watch the video. We're not going to do everything again just because some people showed up now. A lot of people are slightly confused, a lot of people are okay, and nobody has a question. Okay, so let's write some notes. Workflow. Write code in an editor. That's going to be the step 1. We have to write the code somewhere. I really don't care what you use. What I use is called Emacs. We're all going to use GCC or an equivalent compiler. So we write the code, we compile the code, and then we run the executable we have made of the code. If you're using an integrated system, like in Windows, you might need to double click on the executable after it's created. It might like make an icon for you. And on the website that Saul suggested to you, there's a literal button that says run. And that button will combine the steps 2 and 3. It will first compile the code and then execute it. In step 1, what we really need to do is be looking at our reference card, which I said everybody needs to have at hand at all times. And like the question, like what's the A to I command for? This is where we took the A to I command from. We took it from here. It was under stdlib. It's here in conversions. It converts a string to an integer. So now, do we know what the words string and integer means? We talked about integers a lot last time. We were discussing how integers are the way in which we represent whole numbers, like numbers that don't have decimal places. But now, what on earth is string? Apparently, string has something to do with this char thing here. And that char thing actually would be better pronounced as car because it comes from character. So basically, a string is a sequence of characters. And in C, what that's going to be, it's going to be an array. So every sequence of characters is an array. And this is an array of characters. So what on earth? I'm going to go to the whiteboard so we can start trying to understand what's going on here. This is actually literally a pointer, so when we start reading the book, we're going to understand better. But I know it's helpful to have an idea now of what does this mean. So, an array means that instead of just one variable, I have a variable that's divided into individual chunks. And I can index these individual chunks. The first one's going to have index 0, like we saw a little while ago, then 1, 2, 3. So for example, if I have this array, its length is 4, and the indices go from the index goes from 0 to 3. So this is what I'm doing in the program there. The name of the executable lives in the first one. Then here I put the strings that will represent the values X, Y, and Z. And now, these are all also arrays. They all contain several characters. Like, let me see where I executed the last time, so I know what the characters were. So we had a slash dot something else. Right, so it's a dot slash. And is it a slash or a backslash? It's a dot slash. Something else is stored here in the first position. And the thing we're using to represent the value for x, it has two characters, 2 and 3. Here we had a 1 and 2, and here we had an 8. So basically what lives in the memory are 4 locations, and each of these locations contains another array. This one just has the 8, and then there's a termination character. This one has the 1, 2, and a termination character. This one has the 2, 3, and a termination character. This one has the dot slash something else and a termination character. So basically, if I would want to look at the third character in the first one, I could. We could index it twice. Returning to the computer here, let's add one printing. So we would take the first string in index 3, and then its third character would be in index 2. Compiling, running. So it's an S, because this one's the 0, this one's the 1, and this one's the 2. So I can index first which one do I want from the sequence, and which position in that sequence do I want from there. If we want to do the same kind of stuff in a higher level language, everything is much more comfortable. Like, let's say I would like to interact with Python in a similar way. If I would want to have like a list of characters, and then I would want to combine all of those together. Basically, what I am doing is something like this. I could put it in a variable, then I could tell it, give me from the first word the third letter. It's the same exact logic, but I don't have to think about the fact that this one is also a list of characters and this one is also a list of characters. If I really wanted to, I could separate it so that I can see that those are separate ones. It works exactly the same. Whereas in C, they are always separate ones. You have to handle them kind of as separate ones. But when something in your reference card says string, when it's here, it here talks about strings, like here, convert string. String always means an array of characters. That's what it means in C. It's always going to be an array of characters. Okay, I'm going to take out the premature return. We're still mostly just looking at the stuff we did last week. I've lost one of my terminals. Compile again. So we have if and else if. All this is in the book. Please don't panic. We have a while. We have a do while. The difference between whiles and do whiles was that if the condition never fulfills, the while never does anything. Whereas the do while always executes one time and then it starts checking the condition. And the for is the thing we're already using here, where you have an initial condition, like an assignment. Then if the cycle condition is valid, then you do the stuff here on the inside. And then you do the final stuff here. Then you evaluate again. If it's still correct, you do this stuff, and then you go here. And you evaluate again, and you do this stuff, until this condition isn't valid anymore, and then you just leave. So the other thing we were learning last time was that we needed to put our code online. So now if I ask my Git, what's the status? It tells me we have modified test.c. So I could tell it that I would like to schedule the test.c for update. So now it says it's to be committed. I have to give a message. It makes the commit, and with the push, I send it. And then you all can see the changes in the repository. If you haven't cloned or linked my repository yet, you could do it now. Let me find my Discord. I'm very good at copy pasting. Come on. There we go. So now if we go look at this repository, it knows that I just did this commit here. It's going to explain when this happened. It's going to show all the changes that I have made. I could write comments on it if I wanted to, or I could just go look at the file itself. There's lots of different views for this, and I can go look at what the file looks like now. Okay, so you guys don't really need to know how to do any of these things yet. We're just trying to figure out how these tools work so that when we actually do start with the textbook, we are going to be familiar with what's going on. So what I would like to do now is, I'm supposing everybody already has the textbook because I kind of told you to get the textbook. I would like to practice how would we carry out the examples of the book while we are reading the book. First, I'll show how to do it on my computer. Then we will look into how to do it on you guys' computer until everybody is actually able to do this. And after I use it on my local computer, I'm going to use it on the online GCC thing, so I can use it there as well. So, I am going to be looking at the first chapter of the book. It's called A Tutorial Introduction. I'm supposing you guys actually will bother to read all the preface and introduction and everything, because it's really important you read it. When you skip content, you can't really be upset when you don't understand. So, in section 1.1, Getting Started, it's going to explain how to make a program that just prints Hello World. I'm going to take a screenshot of what this looks like on my Kindle of the very beginning so that you guys can find the same place in the book. So now, if I want to start working with the book, if I want to start learning with the book, I could make here a code. For example, let's say that in my editor, I want to make a code, for example, it's from section 1.1, and it's the first one, maybe like this. Then whatever the book says, I will write. So it says we need the include stdio.h. We need this. Book says we need it. I write it there. And the book tells you everything you need to write. You can just write the main like this. You can put the curly brace here. I personally like having it here. You can write here the int if you want to. You could write the stuff that goes inside here. But I think the compiler is not actually going to force us to. Let's see in a second. And here we write what the book says. Hello world. And then the \n for the new line. And we didn't actually write any return there. We've left it kind of like optional. Now we're going to go compile this particular code. And now in the book it says CC, which is C compiler. We're using the GCC, which is the GNU C compiler. Okay, so I have a warning because it doesn't say int in the beginning. If I don't want the warning, I add the int, and now there's no warning. The default executable is the a.out. So now I have an a.out that says hello world. Now let's see. Okay, I think in my computer I could just use also CC and the exact same thing would happen. If your computer says with CC that it doesn't exist, it probably means that your CC points to something else. My GCC and CC both actually point to a program called clang. Okay, so let's try this on the website. So we wanted to go to the online thing. Notice that what's here by default is almost entirely the same thing that was in the book. So we'll just get rid of some of this stuff. I'll take away the int. I'll make it as minimal as it is there. Let's see if this one complains if I don't put the int in front. Forget to choose the language every time. It gives the same warning that it defaults to an int. If I add here the int and I run again, now it just says hello world. Now the hello world here looks slightly different. And I would recommend first to do everything exactly like the book says. Everything. So now if you look at what's happening in section 1, it line by line explains every single thing that happens in this code. And then after a section is explained, we get little exercises. So for example, exercise 1-1 is run the Hello World program on your system. Experiment with leaving out parts of the program to see what error messages you get. This is a wonderful thing to do, and we're absolutely going to do it. So, like, we already know that if I take out this F, it's going to tell me that print doesn't exist, print is invalid, and ask me if I meant print F. Great. If I take out the \n because I'm not sure what it's for, it now compiles, but when I run it, it does something weird at the end. Like it doesn't clean the end of the line anymore like it used to. I add it and I compile, and now it looks a little cleaner. If I take out the semicolon, it says expected semicolon. Okay, so let's put the semicolon. So this way you get to kind of like get used to all the possible error messages. If I take away these parentheses, it doesn't like it because now it's kind of like it's a variable, but it's not really a variable because there is a brace opening here. I need those parentheses. And if you put the stuff here that I had before, the int and the char, it's going to work just as fine. But if you put some other types, it's going to start complaining that either you need to put the right types or no types. If we add here the return, it's just as happy, and it's going to do exactly the same thing. Okay, and then the book also says try putting stuff here because there's the \n. We could also use a \t, which according to the book is a tabulator. So now I have a tab here. And it says to experiment with other characters that aren't tabulator and aren't n. And it's also asking me what's going to happen if I put the double \. Well, it just types one \. So this is how you learn how to program. Not by listening to me, but reading little by little the book. Doing every single thing this guy tells you to. Well, these guys. If they say run the program, you're going to run the program. If they say leave out parts, leave out parts. Don't skip it just because you think you understand it. If you skip it, then you're not going to know this stuff further on. So what he's going to do here is give codes, discuss them line by line, explaining every single thing. When you don't understand the explanation, even after you tried, just take a screenshot of the part of the book, post it on the channel, and let me know what part you don't understand. But if you don't try this stuff, you will never ever learn any of it. So what I would like everybody to do today, you don't have to stay connected if you don't want to, but I would like everybody today to be able to deal with section 1.1 of the book. Get to the exercises 1-1 and 1-2. I will expect you guys to do all of those exercises, not because you get points for them, but because you're not going to be able to do any of this if you don't know how to do those things. So let's close this. Let's add this very lame example. In the repository. And now what I'm gonna do is I'm gonna check some of the repositories you guys linked to see if there's any trouble with them. Then we're going to establish what are the goals that everybody needs to reach between now and next class. And then you all will choose to your own liking how and when you would like to reach those goals. I will be here with you until 5 o'clock today to help you individually, interactively to get these things done. If you would like help, you will share your screen on Discord, either on the live screen sharing or take a screenshot and post it on the channel. And me and the other participants will help you figure out what's wrong with what you're doing. If you want to get much further ahead, you can do so, but please don't confuse the other participants. If you're far ahead, go to the category that says Estudio Independiente on the channel Programming and talk there, or in Book Club, there's Koenig and Ritchie C, you can talk there. So that the class channel, we can keep it to the people who are trying to go with the rhythm of the class schedule, so that they don't feel bad when somebody else is doing something way more advanced. So let's open a few repositories here just at random. As you can see, I'm never going to be able to look at everybody's repository. That's absolutely impossible. Or we're going to have to figure out a way to kind of like everybody checks a few, because 73 people signed up for a class is like way too many. So basically, next week, everybody needs to have read the entire first chapter of the book. And I am expecting for everybody to have done all the little exercises in the first chapter of the book. What we're going to do together is we are going to check if there's any confusion, anything you didn't understand in the book. Then everybody's going to answer the first 3 exercises in the online system. And then we're going to define what your actual first programming assignment will be. And we'll do that together in class. So what we start doing now, and you finish it sometime before next class, is the entirety of the first chapter. And every single code that comes in the book, you will type it in an editor. You will compile it, you will execute it, and when the guys tell you to mess with the code to find out what it does, that's exactly what you will do. So for example, Edgar here made a lovely repository. It doesn't have any test code yet. Let's see here, the same thing. It would be really cool if everybody would get a test code today, even if it just prints hello world, so that I can be sure that we're uploading the code correctly. I think everybody just made a repository at this point. Yeah, none of these people have any code. So we're going to try to get some code in everybody's repository, even if the only thing that this code does is print hello world. I would like it if you are at this point aware of what conditions and cycles are, if you retained some information on what arrays are, but we're going to go in detail into all of those things in the first chapter. So basically, we're going to start reading the chapter together. We're going to discuss whatever you don't understand of the chapter, and quick people might be able to finish the chapter before 5 o'clock today. If you don't want to do it all today, if you want to do it later, you may do so. It should be entirely okay. I'm not going to check 60 repositories right now, so if you've uploaded something, that's lovely. We're going to look at some of them at random. If you don't know if you did it right, you could just link the repository or the file so that we can look at it. But if there's any question you would like to be included in the stream, please type it now. And Okay, so there is a question of how does one upload a code in the repository. We were discussing this a little last time. I'm using a thing called a GitHub Desktop, and I have it locally installed on my computer. You could install it too. You can get an application called GitHub Desktop. It lets you do all kinds of things in all the repositories that you have. But the easiest way, if you really don't feel up for it yet, you can go to your repository. Let's put it here, mine again. Here it says add file. So you could either create it right here, which is kind of a bad idea, or you could upload it. So let's open another tab with the GCC thingy, if I can find it again. This thing here. So let's say I want to upload this code. So what I'm gonna do is first I'm gonna save it. Let's log in with GitHub. Okay. It wants to make a new project. Test. Okay. Now I was going to... Okay, looks like I can download it. And since I'm using my GitHub account, I would like to think there should be some way to put it there straight away. Share, embed, fork. Maybe it shows up straight away in my GitHub. Let's see. I've never used this online thing before. But we're going to upload this main C manually, regardless. Let's go see here. Okay, so now if I would go to add file, I'd go to upload files. Here's the main C that I made. You can make as many WhatsApp groups as you'd like. I don't use WhatsApp. I will not be in any of them, nor will I respond to any questions of discussions in the WhatsApp. If you would like me to respond to a discussion, please have the discussion on Discord. So now I am dragging and dropping the main C here. I'm uploading a file. And now there is a main C that I just uploaded. So that's the easiest way. It's not the most professional way, and it's slightly silly. If somebody figures out how to send things from here to GitHub straight away, please let me know. I'd like to know if I actually have a... Oh, I don't have a test repository now, so I'm not sure where it went. Or if it went anywhere when I clicked on it. But you can download them and you can put them up there. I do everything in the terminal, and most professional programmers will do everything in the terminal. If you are a Windows user, this is probably not what you want to do. If you're planning on being a professional software developer at some point, I would really recommend installing VirtualBox. And into VirtualBox, I would install some kind of a simple Linux distribution, like this one here, so that you could start getting used to working in shell and terminal. So shell and terminal refer to this black window that I keep constantly using, whereas type stuff like Emacs and GCC and Git, all that stuff that I'm doing here. So that's if you really want to be pros at this. If you just need to know a little bit of programming to be able to talk to programmers later on in your professional career, you don't necessarily need to do all this. You'll probably be pretty fine using the online GCC thing. It shouldn't be all that difficult. Please remember that you really need the reference card. Like I've linked one here, and I have one saved on my desktop. Might be the same one, might not be the same one. You really need this. and you really need the textbook. You cannot operate if you don't have the textbook. It's absolutely impossible. I don't care if you read it in Spanish or in English, but you have to have the textbook. You have to. And when you want to learn about stuff like how to use GitHub, just type stuff like GitHub, cómo usar YouTube, and you're going to find 3 million videos that will explain you how to do this. And if you're using it on a Mac like I am, you can just add Mac and you get slightly less results. Or if you're interested in Windows 10 in particular, just limit. It's really easy to find instructions. Like most tools that you use as a programmer, nobody ever teaches you how to use them. Someone just tells you, you should use tool such. And that's the whole thing. Everybody's like, hey dude, you need to use GitHub. And they're like, okay, let me look it up. But that's how we function, because the new tools, they keep popping up. There's like something new every 2-3 months. And we need to go see, okay, let's find out what is Slack. Let's find out what is Stack Overflow. Let's go find out what is SourceForge. We need to figure out all these things. We can't wait for our boss to arrange for a course where somebody teaches us how to use these things. We just have to go and find out. So the most important thing that you learn when you start to program is you learn to learn. You learn to read books and you learn to find out how to use tools. And if you're lucky, you have somebody, like you have me now, who's actually willing to sit around with you a few hours every week to see what you're doing and to try to figure out how you should be doing it. But the actual learning will be you reading the book, you writing the code, and you uploading this code in your repository. Okay, any other questions before we close the stream and I join you guys on Discord? Okay, someone on Twitch is all good. Edgar, Damian, Moises are writing. Okay, Moises thinks it's all clear. I'd be really happy if most of us were able to do the section 1.2 stuff. There's going to be a little code that converts between Celsius and Fahrenheit. That's like the minimum we should be able to do today. Then section 1.3 is going to be about the 4 cycle, so that should be good too. 1.4 is going to be defining constants. Then in 1.5, we're going to start reading input from the keyboard, and we're also going to start wondering what other ways are there for printing other than the printf. So by the end of the chapter, we should be able to work with like a lot of input coming into our program. If we start panicking with any of this, let me know. Section 1.6 is going to cover the stuff on arrays and the indices that I mentioned. There's going to be also the if, else stuff in there. 1.7, we're going to learn subfunctions, subroutines. 1.8, the call by value arguments, like how do you put stuff into subroutines. Then character arrays, like the ones we were just using, the name of the executable, external variables. There's so much stuff in this chapter, so much. I have seen people spend half a year learning this one chapter, but you don't need half a year. You need to actually concentrate and sit down for a couple of hours and you will understand every single one of these things. So if you don't really make it to the very end of the chapter, it's kind of okay because you can still catch up after we define the homework. But if you don't do any of this between now and the next class, you're going to be so very lost. So please, let's work very hard for the next hour and a half to be able to do all this. I'm going to be, while nobody's asking questions, typing the example codes myself and adding them into my repository so that you will know that whatever is already in my repository should also be in yours. Don't just copy my stuff. You actually have to type this stuff because you don't learn by looking at it. You learn by doing it. So we all have to do all of these things. Let's look at this Edgar's thing. No, it's not going to be any of those. It's well, console application is like the least wrong one. Arduinos are a totally different thing. ARMs are a totally different thing. So I would just go with the console application or an empty project. I don't really enjoy stuff that forces you to make projects because all you really want is just one file. The .c files, they all will go to source. We will later have .h files when we get to that part in the book. So I'm going to stop the recording on Twitch. I'm going to join you guys on Discord. And I'm going to start typing the code from, section 1.2 in my repository so that you can copy it from there. Okay, lovely.